In this video, I'll talk about datasets and variables, just kind of the forms that datasets can take and what variables are and how we look at them. All right, so this is an example of what a dataset, a data table might look like. Up on the top, you have that data, you have variables going across the top, and then rows going from top to bottom. The table on the bottom shows kind of a description of all of the different variables. And so this is a data set that has each county in the US, and it has information like population in 2000, population in 2010, the federal spending per capita, and so on. So basically, this is just kind of a way of organizing all of your data. You have each county, you have basically data about each county, and basically you can kind of think about this as, each row is a county that contains information, and basically there's the same information about each county shown by the variables. So basically we can kind of think about these rows as the unit of observation. And basically the unit of observation is each individual case in the data set. And this might seem kind of like an obvious concept, but sometimes it's not really clear immediately from the data set. And so it might be actually a combination of two variables. So for example, this county data set could have had basically information about counties and over years. So for example, let's say instead of what we had before, it had county and year, and it had multiple rows for each county and multiple rows for each year. And so in that case, the unit of observation might be kind of a county-year pair rather than just the county. And so basically, you do have to be careful. You have to think about what the unit of observation is. Other examples might include just kind of individual level. So for example, if you're looking at data about University of Maryland, it might be about kind of just the graduate students, and it might be the UMD graduate student is the unit of observation. Or, for example, in clinical trials, you might have like an at-risk patient as your unit of observation. And so kind of on the other dimension, you have variables, which are the columns essentially. And basically these are the characteristics of the observation in the data set. And so in the county data set that we just looked at, we have stuff like the name of the county, the state, the population in 2000, and so on. There's all these different variables, but there are different types of variables. And this is very important because the type of analysis that we'll do will vary according to the type of variable that you have. And so let's talk about these types of variables. Basically, there's two main types, categorical and numerical. There's also different names for these. There's qualitative versus quantitative. So qualitative meaning categorical, quantitative meaning numerical. And so there's different names, but basically they mean the same thing. Categorical variables are things that kind of are typically thought of as like words or just kind of descriptions. And so within categorical, there's two types. There's nominal, and so these are unordered categories. So it might be like color, like red, blue, green, and so on. There's no natural ordering to them. The other kind is ordinal. So these are ordered categories. And so this might be, for example, like sizes, like small, medium, large. There's a natural ordering. Small is smaller than medium, medium is smaller than large. And so there's that natural ordering, but there's still kind of categories. They're groups rather than numbers. And then you have numerical variables. And there's kind of two different types of these. These are discrete, so whole numbers. For example, how many people are in a class. Versus continuous. And so this might be something like salary, where it's just kind of a continuous scale rather than just whole discrete numbers. And so a lot of times it's easy to kind of fall into the trap of thinking, if it's numbers, then it's numerical. If it's not, it's categorical. But what's going to happen is many times people kind of use numbers to code different things. So they might say something like, 1 equals blue, 2 equals green, 3 equals red. And in those cases, even though numbers are being used, that's still a categorical variable because they represent certain things like red, green, blue. And so you do have to be careful. Basically, when you're trying to differentiate between the types of variables, think about what the variables are being used for, how it's being used, are these groups, and also do the numbers make sense? So for example, if you take the mean of a group of numbers, does it make sense to think about it that way? And in the case of 1 equals red, 2 equals green, 3 equals blue, it doesn't really make sense. The mean, if you get a mean of 2.5, what does that mean? It doesn't mean anything. A mean number of people in a class, mean salary, that makes perfect sense. And so those are numerical variables. Right? So, why don't you take a moment and think about these types of variables? What are these? What kinds of variables are these? So let's go with county name. What kind of variable is county name? Well, these are names that represent each county. They're not numbers; they're just words, and they're kind of grouped by what county there are. And so in this case, the county name would be a categorical variable. What about state? State, the same thing. Basically, they are kind of different categories, and so it will be a categorical variable. What about federal spending per capita? Well, this is a number, right? So this is the amount of money that is spent per person in that county. And so basically, because it's a number, it's like a dollar value. Taking a mean federal spending makes sense, that kind of thing. This is a numerical variable. What about smoking ban? Whether there is a smoking ban or not. Well, this is kind of like a yes or no question. There's actually a different scale rather than just yes or no as well. But basically, the idea is that these fall into different categories, different groups. It's not just like what you can kind of ask. What is the smoking ban? Like 2.5, that doesn't really make sense. And so in this case, it would be a categorical variable. And then lastly, what about income? Income would be a numerical variable. This is kind of like an example that we already used where we're talking about money values. What is your mean income? Well, that makes sense, right? And so one thing that I would suggest you do is kind of go back through and think about, well, are these ordinal? Are these nominal? And also for the numerical variables, are these discrete? Are these continuous? Right, so we've talked about these individual variables, but a lot of times what we want to do is look at the relationship between variables. And so, we might be interested in whether federal spending is higher or lower in counties with high rates of poverty. So does one affect the other? And we can do that in many ways, and depending on the type of variable it is, we're going to be using different visualizations, different measures. But this is one example. And basically this is a scatter plot showing, for each county what is the federal spending and what is the poverty rate. All right, and so we can kind of try to decipher trends based on this. Does it seem like, as the poverty rate goes up, the federal spending also goes up? And maybe you'll conclude that, yeah, it does. It kind of does seem like it's trending upwards a little bit. And so in this case, what we're saying is the explanatory variable, this can also be called the independent variable, is what we think might affect the response variable, which is the dependent variable. And so in this case, what we have is the explanatory variable being the poverty rate, and the response variable being the federal spending. And so many times the response variable is our kind of variable of interest. It's what we want to know more about. And what we're doing is we're using the explanatory variable to kind of explain more about the response variable. And so, and there's lots of, terms that are used for these, independent variable, dependent variable. Sometimes people kind of shorten it to IV and DV. There's lots of, terms for these, but they all kind of mean the same thing. You're just kind of using one variable to explain or talk about an association with another variable. And usually there's this one variable of interest, this kind of outcome variable, this response variable, that variable that we're most interested in. Right? But we do have to be careful. We don't want to say just because higher poverty rate seems to be associated with a higher federal spending rate that one causes the other. So it seems like poverty rate and the federal spending rate are associated, but that doesn't mean that poverty rate causes higher federal spending. So in other words, this is a very common saying, correlation does not mean causation. Right? And so to kind of go over this again, this example of Nick Cage and drownings where these two are correlated, but very clearly there's not a causation there. Nick Cage appearing in more movies doesn't mean that there's going to be more people drowning by falling into a pool. He's not causing them to be drowned in a pool. Right? And lastly, it's this idea of correlation happening. There could be spurious correlations, just kind of correlations that happen by random chance, as the Nick Cage pool example might show. But there's also cases of confounding variables, where basically there's a variable that's associated with both the explanatory and the response variable. And that might be the reason why those two variables are associated, even though there's no direct causation. One example might be, for example, if there was a survey of students and they found that high anxiety was correlated with coffee consumption. Does that mean that coffee causes anxiety? Well, not necessarily. It could be that people who are in high stress situations, who, for example, maybe are taking classes with a high workload, they need more coffee because of the high workload. But that also means that the high workload classes are causing a lot of anxiety. And so, what you have is this, this high workload class as your kind of confounding variable that's associated with both the explanatory variable and the response variable.